Good morning, everyone. Thank you for coming. Appreciate your interest in this talk. Before I even start and introduce myself, I'd love to know a little bit about you. How many people here have tried Cloud Foundry? Okay, about half of you. So, of those of you who have not tried it, how many of you have seen Cloud Foundry demoed? Okay, so most of you have seen it. I am going to start with a quick demo at the beginning before we even get into this, just so we can level set on, at least you'll get a perspective of what I believe and what we believe at Cloud Foundry is the most important thing about platform as a service. So I am going to start with the demo, and then I'll get into the rest of the agenda. So first, by way of introduction, my name is Cornelia Davis. I work in the Cloud Foundry group in a group called Platform Engineering. Platform Engineering is an engineering group, but we tend to be field-facing. So we are not in the Pivotal Labs office all day, every day, like the core Cloud Foundry development is, working on the product, although we do rotate in through the development group where we sometimes will go and pair for a number of weeks on the core product. We tend to be more field-facing. Let's face it, platform as a service is an emerging technology. And so applying that emerging technology is something that's tough for customers. It changes a lot of things. And so we spend a lot of time working with customers and partners, understanding their unique needs, helping them learn how to use this emerging platform, and also extending it. So oftentimes when we're talking to customers, they have a way that they want to use it, or a way that they think they might want to use it, that has never been done before, or we're not that familiar with. It's not day in and day out for us. So that's what our group does. I came to Pivotal by way of EMC, where I worked in the corporate CTO office doing architecture. I worked with a lot of different product groups across EMC, helping them we did emerging tech there and helping them understand emerging tech. During my tenure there, the biggest thing that emerged was that every single product group within EMC started doing RESTful services. So if you went to Ben Hale's talk yesterday, that's what I did at EMC for the last few years, exactly that kind of stuff, hypermedia, how to create hypermedia-driven things, how to really understand REST, what the different properties were, and so on. And so that's a bit of my history. So before we do anything else, let's go ahead and deploy an application. So I'm going to jump over here. And this is the one window that I didn't, that I forgot to adjust for the screen. So bear with me just one moment, and I'll get that lined up. OK, so I'll try that one more time. Sorry, the screen resolution's a little odd. I am going to actually log out and start over again. So the first thing that I want to show you is if you go to run.pivotal.io, just yesterday we unveiled a new homepage on run.pivotal.io. So run.pivotal.io is our public offering of Cloud Foundry. So Cloud Foundry is also offered in an on-prem solution, and it's also available in the open source. What I'm showing you here is the up in the cloud version. So if you go to run.pivotal.io, you will get to Pivotal Web Services. So you can see the logo up here in the top left-hand corner. And just yesterday, we released a new homepage for this, which is really nice because it gives you very quick getting started stuff. So we've been dinged in the past, Pivotal has been dinged in the past for it not being necessarily easy to get started. And the reality is that it's pretty easy to get started on Cloud Foundry, on PWS. We just didn't have all the documentation in place. So we remedied that yesterday, so you can go in here and you can see some examples of how to get started very quickly. There's a Spring app here that you can get started. It'll show you exactly the commands that you need to run to get started on here. So I encourage you to have a look at that. So I'm going to go ahead and log in. And Here we go. So now I am in the developer console. And actually, I'm going to call it the developer and operator console. And you'll see why I say that in just a moment. What I mean by operator console here is you've got a category of individuals now that you're enabling with Platform as a Service that can be your application operators. They're not your infrastructure operators, but they're your application operators. And that's what I mean when I say this is the operator console as well. And I'll show you some of those things as we go along. But I've gone in and I've accessed now my Platform as a Service. I already have a login. And in the upper left-hand corner here, you can see that we have a number of organizations. We have a number of organizational constructs. Ironically, the first one we call an org. So you can see here that we have an org. And I'm a member of a lot of different orgs. We'll stay inside of platform engineering for a moment. That up top level org is something that contains a number of lower level constructs. The main lower level construct, organizational construct that I'm going to talk about here is a space. So you can see here that I've got a number of spaces. This is the organization that we use within the platform engineering group, so you can see that there's spaces for some of my colleagues. So it's a little bit messy looking, but you can see here as well that we have a space called development. We have a space down here called staging that you can't see. It's on the bottom of the screen, and we have a space called production. So you can set up those spaces to map to whatever you'd like. Oftentimes, people will map them to different stages in their application lifecycle, or they might map them to various products themselves. And today, I'm not going to spend, this session is not about giving you a demo of Cloud Foundry. I just wanted to spend the first 5 or 10 minutes giving you a high-level overview. But if you came to a session where we were really just talking about the features of Cloud Foundry, I would talk a lot more about how you might use those different spaces and the different things that you can do with them. At this high level, I'll point out that these spaces do allow you to have a number of different, we sometimes call them policy zones. So this is the place where policies are applied. What are some of those policies? Well, let me just give you some examples. If I click down here into the development space, you'll notice, and it's a little bit awkward because the screen resolution is, I've zoomed it up so that you can see a little bit better. But down here, you can see the team members. So in the development space, you can see I have a lot of team members that are allowed to do things in the development space. But if instead I click into the production space, you'll be able to see that there's only a limited number of individuals, only a small number of individuals here. Where did they go? Oh, just me at the very bottom. And in fact, there's one more, and you can't see it. It's scrolling off the screen. Let me see if I can, it doesn't matter. So very small set of individuals that can do things in this space. There's other things that you can apply in spaces. Increasingly, we're adding more and more there. For example, we have a new feature called security groups. Those can be mapped to spaces. We have placement pools. Those are mapped to spaces. So there's a number of different things that you can control at that space level. The other thing that you'll notice is that contained in spaces, we have applications and we have services. So for those of you who might be a little bit more new to Platform as a Service, one of the things that distinguishes Platform as a Service from infrastructure as a service is that Platform as a Service does not emit what we call infrastructure dial tone. Infrastructure dial tone, what I mean by that is that you are, when you go to EC2, for example, or you go to vSphere, you're going to go and you're going to be interacting with machines, with network pools, with storage volumes. Those are all infrastructure primitives. Here in Platform as a Service, the primitives that you're dealing with are applications or services. You don't see virtual machines here. And in fact, under the covers, these applications don't map to virtual machines at all. They map to containers. So you're not dealing with infrastructure primitives. We sometimes refer to that as application dial tone. And I'll show you what some of the things are that we emit at the application dial tone level. Wow, that was rough. I hope that everything's okay back there. So I'm going to go back into my development space, and let's go ahead and deploy an application to that very, very quickly. And let me make sure I'm in the right place. Go into this tab. And the first application, bear with me, the first application that I'm going to deploy is a Ruby app. I recognize that I'm here at SpringOne. I promise I will not stay in the Ruby world for very long. We'll spend the rest of the talk in the Java world and in the Spring world in particular. But here's a very simple Ruby app. It really just consists of 3 files. Oh boy, they're going to be sweeping up behind me for a while, I guess. I'll have to compete with that sound. There's really just 3 files here. You can see that there's actually 6 files in the directory, but there's really 3 files that are of most importance. app.rb is the application code itself. config.ru defines things like the command that's going to run when you start the application. And the gem file lists dependencies. So this is a little bit like your Maven POM file. It lists the dependencies that this application has. So I'm going to go ahead and deploy this. I'm going to do a cf push. I've already logged in. So I've logged into that same cloud that I've logged into in the UI. So I'm going to do a cf push. And there's a number of command line arguments. In this case, I'm going to set the amount of memory that this application uses to something very, very small. And then I'm going to give it a name. And there we go, hello SpringOne. And I'll click enter. And that's it. So when I said it really is easy to get started, it is that simple. I'm going to deploy this application. In a few seconds, you'll see that this application's deployed. So very quickly, stepping through, what you'll notice is that we've uploaded the files. So we've uploaded the 6 files. We create a tarball. We upload it up there. And now what's scrolling on the screen is what we call the staging process. So you'll notice that you did not have to bundle anything with those Ruby files. I just uploaded those 6 Ruby files. I didn't have to bundle the Ruby runtime. I didn't have to do all of that stuff. So that's what we did in this staging process, is we take those application bits and we lay down, we recognize that it's a Ruby file, we lay down the runtime context, then we put your application into it, and that's all what we do during the staging process. So you can see here that we grabbed the appropriate version of Ruby. We also went through the gem file and we took a look and we grabbed some of those dependencies. And at the very end, you can see this message that says uploading droplet. So uploading droplet is that staged environment. So it has the Ruby runtime, it has your application bits into it. What we do is we generate a tarball of that and we call that a droplet. So it's kind of ironic that what we call an application, which sounds big, is actually small. You can see here that it's 1.8K. And then something that sounds small, a droplet, is actually much larger. So, but that's what happens when you let engineers name products. So we have a droplet, and we upload that droplet, and you'll see why we upload that droplet. We call this the compilation step. Now I've got the application, it's started, so let me go ahead and grab this URL, and we'll come over here, and let me get rid of a few of these things. And there we go. There's my fancy web application. Now, I keep my web applications super, super simple and keep them very hello world because I just don't want to get distracted by anything fancy. The thing that I want you to pay attention to here in this particular case is just this port number. So you can see here that we're running at port number 62698. So remember 698. Now, I'm going to come over into the command line, and I'm going to jump into a different window so I can keep that one open. One of the things, I talked about emitting things at the application level. So one of the things that we emit at the application dial tone is logs. So logs around your application. If you've been doing ops in the past, or if you have some colleagues that are doing ops, I realize that we're more in a developer-oriented conference here, but if you've ever had to do some of that ops, if you wanted to take a look at your application logs, you might have to find the machine on which your application load is running, SSH into the box, and start poking around and looking for logs. Instead, what we do here is we say, no, no, no. We don't want you to concern yourself with machines. We want you to just be able to deal with applications. So we give you this ability to say something like cf logs, hello SpringOne. And now what we're doing is we're tailing the application logs for this. So if I come back over here, and with any luck, I'm going to tail, there we go, tail the application logs. If I generate a little bit of traffic now on this, you can see that I'm just refreshing the page a couple of times. I come back over to my logs, and you'll start to see the log data streaming out here. Now you'll notice here that there's application logs, so this is what's generated by the application itself, really simple stuff. But it's not only the application logs that we aggregate. You can also see that there's a message here from the router. So there's a router that's routing traffic to that particular application instance. We're aggregating the logs of what's going on the router as well. And you'll see in just a moment that I will also show you some other components within the platform that are giving you insight on what's happening with your application on the platform. So let me come back over here to the UI. I'm now going to refresh the page here, and you'll see that that new application has been deployed. There it is, Hello SpringOne. I'll click down into that. And again, it's a little awkward because of the limited screen real estate. But you can see here that it gives me some metadata around the application. I'm running a single instance. Remember the 128 meg of memory. There's the one instance. And if I scroll down here, you can also see the logs as well. Now you'll notice that not only do I have the application logs, but I also have staging logs. So all of that stuff that happened around staging the application, that's captured in these logs. These logs, by the way, can be connected into whatever your log aggregation solution is. So if you've got Logstash or Splunk or something like that for log persistence, you can connect those in very, very easily. So you can see the logs there. You can also see the events. So you can see that I've created the app, updated the app, started the app. Let me do one more thing. Let's do another operations thing here. So I want to scale this application, but before I hit save, and what I mean by scaling the application is I want 2 instances. Before I hit save, I'm going to come over here, and I'm going to do a cf-apps. And I have to be fast. You'll see why in just a moment. So at the moment, you can see that I'm running a single instance, Hello SpringOne. I want a single instance running, and I have a single instance running. So it's one of 1 instances is running. So I'm going to see if I'm fast enough. When I click Save on this, I'm going to come back over here, and I'm going to say cf-apps. I was fast enough. Good, I was really fast enough. So notice that I just did cf-apps 3 times real quick. The first time you can see I was still I desired only 1 application. The next one you can see that at that point, the platform knew that I wanted 2 instances, but I hadn't spun up the second instance yet. And a second later, it had spun up the second instance. So the reason that we can do that very quickly is because we don't go through that staging process again. Remember, we captured that droplet and we uploaded it? That compilation process allows us to take that droplet, which is already prepared, and when I scaled that second instance, I created a container, unzipped that tarball, and started up a process. And I can do that all in less than a second. So I can scale from 50 instances of an app to 100 instances of an app in about a minute. So super, super fast scaling. Let's see what happened over in my logs here. So you can see that if I scroll up, so you can now see somebody else must be hitting this, because I have here application instance 0. Remember, those were the first 2 refreshes? Somebody's gone and accessed my Hello World app, because you can now see that somebody's accessed app instance 1. So if I come over back into my fancy web application and I hit refresh a few times, remember 689 or 698 was the first, and now I'm also running on port 078. So 698 and port 078. And again, going back to the logs, you can see here that I'm getting traffic on both app instance 0 and app instance 1. Now, the last thing that I'm going to do in this high-level demo before we jump into the Spring app is I'm going to show you a little bit of the high availability. So one of the things that the platform does, and has to do, we believe it has to do this, platforms have to do this on your behalf, is if something goes wrong with your application, we want to try to save you. We don't want to just have you paged in the middle of the night because your application went down. So I'm going to simulate that here by having a broken part of my application. I have a link, a part of my application that's at the URL /broken. That's going to crash my application. And so I'm going to go ahead and hit enter on this, and the application's crashed. Now, if we come over here and we do a cf-apps, if I'm quick enough, you can see that there we go. I only have a single instance of that app running right now because I've crashed it. And if I do a cf-apps, the the demo gods are not smiling on me today. Oh, somebody stop hitting my broken link, please. So stop hitting the broken link for a moment. Somebody hit that second broken link, but let's go ahead and do CF apps. See how that is? Somebody's trying to cause problems for me, and they're hitting that broken link somewhere in the audience there. And you guys are crashing app instances. But notice that we're restarting them for you. So if I come back over into the logs here, we can scroll up and we'll see, for example, that the stack trace is showing up in the logs. Some of the other things that you'll notice is that there's now a new kind of actor that's showing in the logs called API. So this is also showing you that an application has exited. So it's giving you all of this messages. It's aggregating everything. And by the way, those two app instances, those were running on two totally different machines. So I didn't have to SSH into one box and check out the logs and SSH into a different box and check out the logs. It's all aggregated for me.
Do user sessions get restored when the apps come up?
That's a good question, and in fact, I'm going to ask you to hold off on that because we're going to talk about user sessions when we talk about the Spring app as we go along. So it depends. If the short answer is if you've written your application in the right way, then user sessions will be cool. But in fact, you're asking an outstanding question. If you remember we had a 698 and 076 or something like that. If I come back to my app now, and I do a refresh of the non-broken part, notice that it's a completely different port number. So we do not try to take that application container and kind of fix it up, because you know that as soon as you've crashed an application, all bets are off. It could be totally corrupt. The environment could be totally corrupt. You don't know what else has gone wrong. So what we do is we say, you know what? We're going to start from scratch. Of course, that means that you're going to need, and this is where we're going to start to get into the meat of the talk today, that means that your app instances shouldn't be, they should be stateless, because we're going to start up fresh copies. And those are some of the architectural patterns that you're going to see when you start to build applications for the cloud. And if you do follow some of those architectural patterns, then you get these types of benefits from it. Now, some of that state, you were just talking about a specific part of that state, which is user sessions, and we'll come back to that. So that's one of those exceptions that we allow around, things not being totally stateless. Okay, excellent. And so, by the way, that was a great reminder. Please do stop and ask me questions. If we start to get a little bit behind on time, I may ask you to hold, or we'll take some questions offline. But I'd rather you ask the questions in context. So please do ask me questions anytime. Okay, very quickly, let me show you what's happened under the covers when we did that. I want to push an application. If you remember, we had the application bits, that's what this little square box is, and then we had application metadata, like the number of instances, the amount of memory I'm using, the URL I'm going to use, and so on. Some of that metadata that you saw when I showed you it in the UI. What happens when I push that application is I upload those things. Inside of the platform here is shown in this box. Inside of the platform, we have a blob store, and we have a database that we call the Cloud Controller database. So those things are uploaded into the system. We have the API endpoint is what we call the Cloud Controller. So all of my API, every time that I did things like push or scale, those types of things are all going through the Cloud Controller endpoint. We also have a high-level construct called service brokers. Service brokers allow you to tie your application bits to services such as databases, message buses, performance monitoring, search services, those types of things. So I'll show you some of that as we go through the Spring talk. And then we have a whole stack of these, what we call DEAs. DEAs stand for Droplet Execution Agent. So droplets, remember, are the prepared applications. These are the virtual machines that are responsible for running those prepared applications, running those droplets. So the first thing I do is I upload those bits. Then I didn't show it in this particular instance. We'll see it later. We create bindings to those services. And I'll talk about, at a very low level of detail, what's going on with those bindings. Then we are going to, hit the wrong button, stage the application. So if you remember, you saw the staging scrolling on the screen. What we're doing there is we're taking something that's called a build pack, and we're using that build pack to do the environment configuration for your application. So the build pack encapsulates what that runtime environment looks like. In this example, we used the build pack for Ruby. We also have build packs for Java, Node.js, Golang, PHP, Python. I'm probably forgetting one. And by the way, if build pack sounds vaguely familiar, yes, it's exactly the same build pack concept as Heroku. It's an open specification that we used from Heroku. So I am talking about Heroku build packs. They work on Cloud Foundry. So we go through that staging and we create the droplet. Then we deploy the application, which I told you is just a very simple download the droplet, create a container, download the droplet, start it up. And then I showed you about some of the stuff that we do around managing application health. Okay, so last couple of slides before we start drilling into the lower level details of running your Spring apps in the cloud. I do want you to understand, if you haven't heard this before, I want you to understand what motivates us. What motivates us in everything that, when we're thinking about putting a new product, a new feature into the Cloud Foundry product, we are motivated by certain things. And fundamentally, we're motivated by this. Software's eating the world. Now, if you haven't heard that term, I encourage you to look it up. Google Software's Eating the World, Wall Street Journal, and you will find an article that was written by Mark Andreessen back in 2010, I believe. Back then, it was maybe still a little bit provocative and kind of leading edge. At this point, people have pretty much accepted that software is eating the world, that every single industry out there is being impacted by software. It could be an industry that was already software-driven, or it could be an industry that was not software-driven before. So you can see, for example, that right there in the middle, we've got Monsanto. Monsanto is a Cloud Foundry customer. You wouldn't necessarily think of farming as being technology-driven, right? But it is. So somebody recently asked me when I talked about this slide, they said, Monsanto, what the heck are they doing? So they, for example, they're all about farming in the large, huge farms. They're gathering soil samples. They have sensors on the tractors that are out in the fields. They're a big data company as well. They're gathering tremendous amounts of data, processing that data, and trying to maximize crop yields, those types of things. So you can see some other logos on here. Nest, of course, huge acquisition by Google. But my favorite one to talk about is actually Uber. And this is an old slide. The valuation of Uber in the last, this slide is maybe 6 months old. Now the estimated valuation of Uber is close to $20 billion. It's huge, totally disruptive. Now I live in a smaller town, so I was very late to come to the Uber game. But I've been traveling a lot, and I finally downloaded Uber onto my phone. And the first time that I called a cab via Uber, I was like blown away. Because I'm not I'm not very good at hailing cabs in New York City, and so I didn't have to stand there on the street corner and go like this and watch one after another go by me and feel rejected and all of that stuff. I could just go on my Uber app and say I'm here, and it would tell me in 2 minutes, and I could watch the car, and I could watch the car on my phone and go, oh, there they come. I know what car they're driving. I know the name of the driver. I can contact them via SMS or phone or whatever. Very, very cool. And I was waxing eloquently with one of my colleagues in the New York office about how I was blown away by this experience and how disruptive this is to the transportation industry. And of course, New York City, it's all about the yellow cab, right? And they said, when you think about it, it's really disrupted even when you think about how it's disrupted the New York City cab system. In the cab system in the New York City environment, you had to, in order to run a cab company, you need a medallion. So these medallions were always sold, and probably still are, on the black market. And I was thinking, oh, for tens of thousands of dollars? No, hundreds of thousands of dollars, millions of dollars, these medallions, so that you can run a cab. You can run a cab company in New York City. And of course, why were they that expensive? Who was selling them? Organized crime. The cost of these medallions has plummeted in New York City because of Uber. So software is not only disrupting Monsanto and everybody else, it is disrupting the Godfather. I mean, seriously. I mean, it's really disrupting the world. So I wanted to share with you that story because truly software is eating the world. And everything that we do, what we want to do is we are building a platform so that you can bring software to market faster, but even more importantly, more frequently. This Facebook that you use today is not the same as the Facebook you used yesterday. The Twitter that you use today is not the same as the Twitter you used on Sunday, right? You can buy stuff on Twitter now. It's changing all the time. So we want to enable you to bring your software to market faster with higher quality, continuous deployment, be able to deploy daily, weekly, whatever you want to do. So that's what motivates us. All right, so let's get over to Spring now. So I apologize, it's taken a little bit of a long time, but I wanted you to understand what motivates us and what we're doing here. So what we're going to do today in the rest of this hour is we're going to take an existing Spring application and get it up and running on Cloud Foundry. So it's very, very pragmatic. I realize that some of this stuff, talking about disrupting the Godfather, is a little hand-wavy and high in the pie in the sky. But we're going to be very, very pragmatic now and very tactical. This is an application for those of you, how many of you were here 2 years ago at SpringOne? Oh, only a handful of you. So some of you may have seen this. Spring Trader was an application that was debuted at SpringOne 2 years ago. And it's a reference implementation. It's a reference application. It's an application that was used to demonstrate a whole bunch of different pieces of the Spring platform, really the vFabric platform. It was the VMware vFabric platform. So it was used to demonstrate things like tcServer, Gemfire, SQLFire, RabbitMQ. These were all components that were brought together in this application. The application is a very simple stock trading application. You see a screenshot on the left-hand side. You see a high-level architecture on the right-hand side. Very, very simple app. It basically allows you through the UI to go in and do things like view your portfolio, execute stock trades, buy and sell stocks. And that's all happening with boxes A and B. There's a web tier, and there is a services tier that is serving this UI, the RESTful services behind the UI there. Then there's a fulfillment tier at the very back end, which executes those stock trades. So you're all familiar with the fact that when I say, hey, I want to buy 100 shares of VMware or 100 shares of EMC, my two parent companies, it doesn't happen instantaneously. When you put in that stock trade, it queues it up, and sure, within a second or 2 or 5, it's executed that stock trade. Well, that's the same thing that's happening here. So you enter your stock trade, and then there's a back-end fulfillment tier, which is box D, which pulls things off of a queue, executes that trade, and then goes on. Each one of those components, the front tier, which is delivering things to that queue, is connected to a message broker, and the back end, of course, is pulling off of the message broker. And then finally, we have a database, a data tier, which is box E there at the bottom. So very simple, high-level application topology there. What we have is we're going to see that this is 3 WAR files. The WAR files are A, B, and D. And then we're going to leverage a RabbitMQ. You're, of course, not going to build your own RabbitMQ. That's what we call in Cloud Foundry a service that you're going to leverage from your application is box C as RabbitMQ. And box E, today we're going to use MySQL. And I'll show you all that in just a moment. There's a GitHub URL there. I encourage you to take a look, and you can check it out. You can take exactly this and get it running on PDubs. We sometimes call it PWS. We sometimes call it PDubs. So this was the Getting Started guide for the Spring Trader application. And I'm being a little unfair here in that there's actually, it's about half this size because there's 2 different platforms. So it says doing it on Unix or doing it on the Mac. But if you go from here, right here, about a little bit more than the half, you can see that the steps, and I'll read them to you because I know you can't read them, I won't read them all, but here's what you had to do to get this reference application up and running 2 years ago when it was debuted. You had to install tcServer, then you had to install SQLFire, then you had to install Erlang, then you had to install RabbitMQ, then you had to do some configuration, you had to start RabbitMQ, you had to start SQLFire, and so on. All of this stuff before you even could deploy your application. So that's certainly part of the benefit of platform as a service is we say, hey, we make that easy for you as the developer. You don't have to do all those deployment steps. I am here also to tell you that platform as a service is not just for the developer. It's about the operator as well. You saw that in the demo that I showed you already. It's a huge operational benefit to have applications restarted on your behalf. Your application operators are going to be really glad they're not paged at 2 in the morning when we can recover an app. So it's not just about the developer, but certainly it does make things much better for the developer as well. So this is where we started. We started with this reference implementation, and you'll see where we ended in just a moment. So here I am, how many minutes in? I am, oh my goodness, I really need to get going. More than half an hour in, and I'm finally showing you the agenda slide. I won't go through this in detail. I thought that the most interesting thing that we could do is step through what we did to actually take this application and get it running on Cloud Foundry. So there's no better agenda than looking through the commit log for this particular repository. So you can take a look at the commit history, and you can see that what we did was we did a first set of things. We're going to talk about cross-site scripting. We're going to talk about service catalog and the service registry. We're going to talk about Spring Cloud Connector. I'm going to introduce that. There's going to be another session on that following this one. We're going to talk about big A applications and manifests. We're going to talk about services a little bit more. We're going to talk a little bit about auto reconfiguration. Finally, we're going to come back and we're going to revisit cross-site scripting. And then we are also going to talk a little bit about applications that are themselves services. So these are all the different things that we're going to go through. So let's dive in. First thing, so we wanted to take the Spring Trader application and deploy it and get it up and running. And the very first thing that we ran into was this. We ran into a cross-site scripting challenge. So when this was deployed in Spring Trader, when the Spring Trader was deployed on using the old style, it was deployed with these URLs. So the web tier was deployed to something like springtrader.com/web, and the web tier, the services tier was deployed to springtrader.com/services. So we didn't have a cross-site scripting issue. The domain was the same, springtrader.com and springtrader.com. We just had two different WAR files that were running at different places, configured differently in the servlet. One was configured to go to web, and one was configured to go to services. When I deploy those WAR files to Cloud Foundry, I get two unique URLs. Now, the domain is the same, cfapps.io. That's the default domain on PDubs. But the subdomain is different. traderweb.cfapps and traderservices.cfapps. So those two things were different because my two WAR files are deployed as separate applications. That's what we want. I assert that we want those deployed as separate applications because I want to be able to scale my web tier independent of my services tier. Maybe I need a lot more capacity on the web tier and less capacity on the services tier, or vice versa. So I want to be able to scale these things independently. That's why we deploy them as into two separate containers with two different URLs. But that meant that right from the get-go, I was dealing with cross-site scripting issues. So if you take a look at the commit history, you can see how we solved this. We hacked it. We solved it by saying, oh, we were under a time pressure, and you know what? I knew that cross-site scripting wasn't going to be that hard to do, but I didn't know how to do it. And I have drunk the Kool-Aid. Cloud Foundry is now developed in the Pivotal Labs office. Pivotal Labs is extreme agile. They believe in solving today's problem today and solving tomorrow's problem tomorrow. So we took the simplest approach that we could to get this demo up and running, and we just changed the POM file. I'm sorry, the Gradle build file. And we just glued these two WAR files together. We created a single WAR file for the entire front end. And I'm telling you that because that's the way that you'll find it in the commit history. And it gives me an opportunity to talk to you about what the challenge was. This is a solution. Ultimately, we got rid of this solution. I did solve tomorrow's problem tomorrow. So we'll come back to that. All right. So then the next thing, if you remember the topology, we had the different WAR files, A and B, were connected to the message bus. I'm sorry, B was connected to the message bus, as was D. And then we were also connected to the database. How was that done before? Well, in the original project, it was done using JNDI. Well, the abstraction that we use in Cloud Foundry is that we have, if you remember, there was the Cloud Controller database. As soon as you do a binding of an application, a WAR file that's going to run, to a service, we capture that binding, and I'll show you how all of this works by the end of the talk. We capture that binding, and then we make those credentials to your RabbitMQ or the credentials to your database, we make those available as environment variables. So who's heard of 12factor.net? Okay, a handful of you. So I said that what I'm going to talk about here, what we're going to learn about, even indirectly, and sometimes I'll make it very direct, is building applications for the cloud is different, necessarily different, not holistically different, but there are some differences when you're building applications for the cloud. Who here has heard the term microservices used this week? Right? Every single one of you. So that is one of the differences. We don't build monolithic apps anymore. If you want to build apps for the cloud, you want to build them smaller. That's one of those patterns. But some of those other patterns are very well captured in 12factor.net. So the place to look at it is the number 12factor, so it's not 12 spelled out. It's 12factor.net. It was written by some folks that came from Heroku, and they captured a whole bunch of patterns, not only technical patterns, but process patterns of things that they found useful when they started having to build applications for the cloud. So one of those things is the use of environment variables. And so I won't belabor the point here, but environment variables are something that is ubiquitous. They exist on all platforms, and so it's a great way of leveraging bindings between different application components. It is a useful tool for loose coupling, I guess is the short of it. Yes?
These environment variables, are they specific to each space that you described?
Excellent, good question. So the question is, are those environment variables specific to each space, or are they shared? The answer is that some set of those environment variables are specific to the application, and I'll show you that as we go through. And when I'm deploying the application, I can set application environment variables scoped to the application instance alone. That's one option. We have a new feature coming out where I think we call them environment variable groups, where you can apply environment variable groups exactly to the space level so that you're able to say everything in this space shares these environment variables. So you're right, you can start saying, hey, when I'm in my development space, my environment looks like this, but when I move over into production, my environment looks like this. And we'll come back to that. We'll see concrete examples of it. Great question. Yep, so the environment variables are important. So when it comes to the changes that we had to make to this particular application, in the configuration files, in the Spring configuration, and you'll notice that the Spring configuration here was still XML. It's on my to-do list to transform this all over into Java config, but I haven't done that yet. All of the config for this application written 2 years ago is done in XML still. So you can go into one of the Spring config files and you can find this line, which is the JNDI lookup, and we've replaced that with, I'll remind you that we have the service broker over here. So this is all around this protocol around binding services. And you can't read it. I apologize, you can't see it. It's exactly the question that you were just referring to. As I have screenshots here, the one in the background is pointing to staging, and the one in the foreground is pointing to production. The point here is that the names of the services, because JNDI, remember that's a naming service. I'm looking up my database binding by name. We do the same thing here. We're looking it up by name. And what's the name? Well, it's the name of the service instance as it is in my space. Now, I could use different names of my services in different spaces, or I could use the same name. So the point that I'm making here, and very poorly with this resolution, is that service instances are scoped to spaces. So I can have Trader SQL in the production space, and I can call it the same thing, Trader SQL, in the development or the staging space. And that means that my configuration can use the same name all the way through my application lifecycle. And that's a very, very valuable feature. So names, service names are scoped to the space level as well. Yes? Yes. Correct. So the question was, in a space, can I have Java and Ruby and other applications in other runtimes, language runtimes? Absolutely. The answer is yes. And they would be able to share, for example, the environment variables. So good point. That's a really great question, pointing to, somebody asked me the other day, environment variables, isn't that kind of like old and archaic? And I said, no, it's actually the least common denominator. Every single one of those languages knows how to access environment variables. So there aren't differences. So really great question. So yes, you can, those things can share in those spaces. So when I do that CF bind service, and we'll see this all put together at the end, what it does is it writes, and I apologize, the screen resolution here is terrible, and I think I picked a very horrible color as well. But I'll show you this live in just a moment. There is a name in there. So you can see the thing you can read is vcap services. I'll show you this live in just a moment. But here's what the new Spring configuration file looks like. Instead of it saying JNDI and doing the lookup via that naming service, it is doing the lookup. See where it says service name Trader SQL? It's still doing a name lookup, but it's using something called, it's using a namespace called Cloud. This is using the Spring Cloud Connector project. And a plug, stay in this room immediately following this talk. Ram Navas and Scott Frederick are going to be doing a talk where they're going to go into the details of Spring Cloud Connector, which is one of the components. It's one of the things that's gluing together that tree that you've been seeing in the keynotes. So this is the new way. Or actually, you could do it much simpler. You could have just said Cloud Data Source ID data source. So the ID is the bean name. That becomes the bean name. You could go without the service name, and we'll do some of that auto lookup magic yourself. So in specific, if you have an application that has an application configuration with a cloud data source, which means it's a database, and you have a binding to a single database, we'll automatically pick up that database, and you don't even have to do it by name. So we do have that bit of auto reconfiguration magic. So let me go ahead and jump over and show you some of this live. So I'm going to Control-C out of this. OK. Oh, wrong key. There we go. And in fact, let me go over. get my bearing here. Okay, we're in the Spring Trader directory, so you can see here's my application. I've got a number of deployment scripts. We'll look at those in just a moment. And so what I want to do and by the way, that Spring Cloud connector, the reason what it is doing is I talked about these environment variables. When you bind a service to an application, what we do is we make those credentials available to you, I mentioned as in environment variables. Which environment variables? In specific, we make it available to you in the VCAP services environment variable. So let me show you that very much live. Let's come back over here into my UI. I'm going to go back into my development space. And I'm going to do the first couple of steps to deploying the Spring Trader application. I'm going to create the Trader SQL and the Trader messaging services. Now, I want to come over here. I'm doing it through the UI because it's a little bit prettier. And I want to show you the services marketplace. So these are all the different services that are available to you on PDubs. So you can see that there's application performance monitoring. New Relic is here today. Many of our other partners are here as well, search services and so on. I'm going to, in this particular case, create an instance of a relational database, the MySQL database. So I'm going to come in here, and I'm going to select the free plan. And I'm going to, it's waiting. So this is where you want to, you hope that the internet stays up. And I'll call it Trader SQL. And I'm going to add that to the development space. So again, these service instances are scoped to a particular space. So I'm going to click Add on that. And that'll create an instance of the relational database for me. We should see that show up in just a moment. There we go, service instance created. I'm going to also create an instance of RabbitMQ. So RabbitMQ is provided through Cloud AMQP in this instance on PWS. Let me select this plan. And now I'm going to go to Trader SQL, call that Trader SQL, and I'll create it in the development space. Okay, so now if I go back to my development environment, in addition to the database that I had before, what happened? Hang on, let's try that again. Did I give it? Oh, I gave it the wrong name. Ah, okay, that's what it was. Thank you very much. That's how you know it's live, right? So let's try that again. I should have said Trader messaging. You are absolutely right. Let's do that again. Select this plan. Thank you. I got an error because Trader SQL was already created. That name was already taken within that space. Trader messaging. Make sure I get the right name. Bingo. Okay. And I'll jump over here. You saw that it showed up. If I do a CF services, you can now see that I have Trader, I have the database that I had before, but I have Trader SQL and Trader messaging. So I've got a MySQL database and I've got a RabbitMQ. So those things I'm going to connect up to my application in just a moment. So I've been talking about these environment variables. Now, as I'm doing development of my application here, let me go over into STS. I'm doing development of my application here. And I want to run this locally. I just want to run it on my laptop. And most of the demos that you've seen here so far, everybody's running at localhost. I'm doing this all on the web. So let me make sure that I reset my run configuration. I didn't, so I'm going to remove these. So let's just say I started from scratch. Let me do an apply. I want to run this application. So here's my services tier, and I'm going to run this. I'm going to run it on Tomcat. OK, let's go ahead and get started. And here's my Tomcat starting up. And uh-oh, hang on a second. I see a stack trace. So something went wrong. Let's see what went wrong. If we read the error message, it says, error registering service factory. Nested exception is yada, yada, yada. No suitable cloud connector found. So remember I was showing you that Spring configuration where it was using Spring Cloud Connector? What Spring Cloud Connector does is it allows you not to have to write the code yourself to parse the environment variable. So I said that the credentials are available to the app and the environment variable. So you could, in your application, write the code that looks up that environment variable, parses it, and so on. But Spring Cloud Connector is what you use to do that for you. So that's what allows you to, in the Spring configuration file, say, hey, here's what I want. And it goes ahead and it looks up that environment variable, does the parsing, and so on for you. Well, if I want to run locally now, I'm trying to use Spring Cloud Connector, and the Spring Cloud Connector is saying, well, wait a minute, I don't know what cloud you're deployed into. Spring Cloud Connector doesn't only support Cloud Foundry, it supports Heroku as well, for example. So it needs to have something that it queues off of to understand what it is, which cloud we're using. So the way that works is it itself looks for the existence of environment variables. So I want to supply in the run configuration, so I'm going to come up here to run configuration. What I want to do is I want to provide those environment variables here in my development environment. I'm going to give you a hint that there's the first one that you want to do is you want to include one called VCAP application. VCAP application is the signal to Spring Cloud, vCloud application, and I'm just going to give it the value of an empty JSON payload. That's something that you want to include, and that gives it the clue that, hey, this is not Heroku, this is Cloud Foundry. In a moment, the other application, the other environment variable that you want to set is VCAP services. So remember, I said that that's where the service bindings are coming from. So I'm going to give it VCAP services, but what value am I going to give it? Well, I've created those two service instances, so let me show you a trick. This is just purely a developer trick that I'm showing you here. So I've got those two service instances, and I've also got my applications. So I'm going to do a CF bind service, and I'm going to bind those two services to an application. I'm going to bind them to hello, SpringOne, Trader, SQL. Okay, and now I'm going to do the same binding to Trader messaging. And now I've got those bindings. Now my Hello World app isn't going to use those bindings, but this is just a little trick that I'm showing you. Now I can do a CF-env on that application, hello, SpringOne. And what that's going to do is it's going to show, do I have a typo? CF-env, thank you. Thank you, Duncan. What that's going to do is it's going to show me the environment variables of the bindings that I have to this particular application. So I click on that, and there you go. I've got the VCAP services environment variable. So here you can see that VCAP services is the environment variable. And notice that it's taken now the ClearDB binding and the RabbitMQ, the Cloud AMQP binding, and it's given me that entire all of the credentials that are in there. Question in the back.
Is there a difference in binding service on the console than CLM?
Okay, the question is, if I do the binding of services to applications through the web console versus the CLI, is there a difference? No. It's just two different, it's just two different UIs for exactly the same thing. No difference whatsoever. Okay, so I'm going to go ahead and grab that. And so what you want to do now is you want to grab that environment variable and paste it over in here into the value of the VCAP services environment variable. Click OK, apply. Let's close that, and let's try again. Let's restart that application. We're going to run it on Tomcat again. And this time, with any luck, what did I do wrong? Oh, I think I pasted the wrong values. So I'm not going to take the time to do it again, but I'm having a JSON parse error, so I must have had a curly bracket off somewhere. But basically what would have happened here is that I've now provided those service bindings to this in my environment variable. Because these are available as software as a service in the cloud, I'm able to access them from my development environment here, and it'll work just the same way. So in the interest of time, I'm going to continue on with this. But I wanted to show you how you use VCAP services environment variable locally. OK, so very briefly then, we have a topology here. So I have 2 WAR files at the moment and 2 services. So how can I deploy what I'm going to call a big A application? The big A application is the entire thing. Little a applications are each of those individual WAR files. So do I need to do a CF create service, CF create service, CF push, CF bind, CF push, CF bind? Do I need to do all of that at the command line? The answer is no. We have the notion of an application manifest, which is a declarative way of defining your application topology. And you can see we added a deployment manifest into the repository as we went along. The basic structure of it, it's a YAML file. The basic structure is that you've got some global properties at the top. So each one of my 2 different WAR files are each going to be allocated a gig of memory. They're all going to be deployed to cfapps.io as the domain. They're both going to be bound to Trader SQL and Trader messaging as services. And then the specific things down here, you can see that I'm pointing to the WAR files, and I'm giving it specific names. The host is the subdomain for my URL. And now I can just do a CF push, and it'll leverage that application manifest, and it'll deploy both the WAR files and bind them to the services and so on. And we'll revisit this in just a moment. And then finally, one of the last things that we did to get this first thing up and running is I wanted to talk a little bit about service plans. So you'll notice here in this screenshot, it's a little bit hard to see, but if you go to pdubs, you'll see that each one of the services, so when I went in and created MySQL and I created the RabbitMQ instances, there were a number of different plans available. I used the free plan in both cases, but then there's also paid plans. And you get different SLAs. You get different criteria. So in this particular case, in the free plan, you can see, for example, that under ClearDB, I'm only allowed 4 concurrent connections to my database. So what I did is we made a modification. Remember this? This was how I changed the configuration from looking up my database binding from JNDI over to using Spring Cloud Connector. Well, the Spring Cloud Connector, so far, we just talked about things like the ID, which is the bean name, and the service name, which I've omitted here. But you can also set some of the values of those. So you can set, for example, your pool size of that data source bean. So in this particular case, we changed the pool size to 2 for the front and the back, so that we're only allowing the front part of the application 2 concurrent connections and the back part of the application 2 concurrent connections, so that in combination, I'm only consuming the 4 connections there as well. So that's just a very, very high-level preview of what Scott and Ramnavas are going to go into in more detail in the following session. And then I wanted to finally share with you just an anecdote, an experience. So we were doing all of this work to get this up and running, and we had it up and running. It was up and running on Cloud Foundry. And we had used Spring Cloud. It was called Spring Cloud back then, now Spring Cloud Connector, to do the connections. And I went to make a modification, or I went to look at a Spring config file. And I went into the Spring config file, and I found this, Rabbit:/connection factory. And I thought, what? I thought that I had used Spring Cloud. this isn't using Spring Cloud to do my binding to my Cloud AMQP. What the heck is going on? This is what I thought I had in the file. So you know how it is when you're trying to get ready for a demo and you're doing a lot of different things. And I was like, wait a minute, I thought I had a version of this where I had. And Spring Cloud Connector allows you to have a Rabbit connection factory, and you give it the bean name, and it's just as simple as the MySQL binding. But I didn't have that in my Spring config file. And why not? Well, it turns out that our build pack, the Java build pack, that Ben Hale is fundamentally responsible for, or does most of the development on, he's the development lead on that, does auto reconfiguration. So it itself uses Spring Cloud Connector under the covers, and it had done the perusing of my Spring config file and had found a Rabbit connection factory, and it had found that my application was bound to a single instance of Rabbit, and it did the magic for me. It rewrote that. And so it rewrote that binding for me so that that worked as well as that working. So some of that Spring Cloud Connector magic happens within the Java build pack, and I wanted to make sure to share that with you. Because, and the warning at the bottom here is that I was doing this all in a development environment, and I had a big, huh, moment. Well, huh moments are not good in production. And so just a warning here that I know that in every session that I've been to, we've been talking about how Spring does a lot of this auto reconfiguration for you and does a lot of magic for you, and that's all fine and good, but I don't like those huh moments, and maybe it's because I'm not nearly as much of a Spring expert as all of you are. So just to share a little anecdote. Okay, so this was the first chunk of work that we did, and we were doing this, by the way, in the context just to share with you. We initially started this work when SAP approached us and said, hey, we would like to partner with Pivotal. We want to bring SAP HANA DB, into your marketplace. We want HANA DB to be one of the things that can be used from Cloud Foundry. So together with SAP, they built what's called a service broker, which you saw on the screen. And I worked together with a colleague from Accenture as a solutions integrator, and we got all of this. We did this work initially to get it all up and running with SAP HANA. And at this point, we had a very, very tight timeline. We got this running. We got it running in time for one of the SAP developer events. And this is where we were, and everything was running just fine. Then, once we had time to catch our breath, we wanted to make a few additional changes. So one of the first things that we wanted to do was I wanted to revisit that hack. So remember the hack at the beginning where we said, we put the web tier together with the services tier because we didn't want to deal with cross-site scripting issues in the tight timeline that we had? So I came back and said, I want to revisit that, and I want to learn how to do this cross-site scripting thing correctly. So first, let me talk about what the issue is here. So cross-site scripting comes up in the following sense, and I really wanted to make sure that I personally understood it. So I'm sitting here, my browser is on the left-hand side, and I'm accessing a web page. So I access a web page, example.com/index.html, and I get back some HTML, and it's got some script embedded in it. And notice that this script, embedded in the script, I'm accessing something from the document, from the DOM of this HTML page. And then, somewhere else, I'm changing that DOM, right? The HTML page there. So I am changing the DOM by making this XML HTTP request. And this is exactly the way that the Spring Trader application is built. The Spring Trader application is an AJAX-style application. It's a rich web application where we're leveraging the XML HTTP object to make requests from the client browser so that we're not doing page refreshes all the time. So it is kind of this rich web experience. So it has this pattern. So somewhere along the line, we make an XML HTTP request, which changes the DOM, and then I've got a script that is accessing that DOM. And that's what's happening here. So I access that DOM, and everything is fine. I'm in control of the web page, and I'm in control of, which means that I'm in control of that XML HTTP request. And notice that the domain is the same. I'm in control of everything. I'm example.com. I'm in control of everything. Well, cross-site scripting, the reason that the specification has made it very strict and that they didn't allow cross-site scripting was what happens when some evil site comes along. So now I've got a web page that is being served by evilsite.com. And inside of that evilsite.com, they're making a request to my web service that's running at example.com. There's nothing to stop that request from happening. Now, of course, you should have access controls on your services tier. No question about it. So access controls are an important part of it. But whether you have those access controls or not, that request coming from the evil site web page that's running in your browser now, that request to example.com will go to the server, and it will come back. And so this is, of course, dangerous, because now that evil script is doing something with whatever is returned from your XML HTTP request. So if you've got some kind of security loopholes in your example.com /foo, they're getting access to that entire DOM, which that is bad. And so that's why they came up with this, we're not going to allow this by default. We're not going to allow cross-site scripting. Of course, especially with the emergence of more of these rich web applications, you do need to be able to do cross-site scripting. And so here's the issue, is that the cross-site scripting, the way by default it works in the browser is the request will go out, the response will come back, but the browser will not allow it to go any further. So the request comes back, but it's not available in the DOM. The solution is, of course, various cross-site scripting solutions, and I'm not going to go into it in detail. I'll refer you to the GitHub repository to see what exactly we did. But basically what we did was we created a CORS filter. And so what that does is it allows you to list the domains that are allowed to be called. So it allows you to list the domains that you say, these are my trusted domains. These are the domains. Evilsite.com is not one of the domains that is going to be allowed to see the responses from example.com. That's essentially what you're doing. So you're creating a CORS filter. So that's all in the GitHub repository. You can see what we did to implement that CORS filter and get it up and running. So that was great. That allowed me to separate my web tier from my services tier. Now, the cool thing now about that is it allowed me to do something very interesting. I didn't call it that back then, but it allowed me to essentially do something that's starting to look like microservices. What it allowed me to do is it allowed me to take that services tier, remember the B box? And it allowed me to use that services tier by another tier, which is the web tier. So it allowed me to take an application, something that's running as an app in Cloud Foundry, but now I want to bind that application as a service to the web tier. So I have an app that is acting as a service as well. Okay, and that's cool. That's where we're starting to touch upon some of the themes that are coming in microservices. Now, Spring Cloud Connector already has support for a bunch of different things. I showed you the data source. So data source allows you to connect to things like MySQL and Oracle and Mongo and those types of things. It also has support for AMQP, so RabbitMQ. Has support for monitoring, so it has support for New Relic, SMTP, and so on. Those are all different things that you can go into your Spring config file and you can say, hey, you can just declare the connection to a service. But it did not have, at the time, it did not have anything that was for the web tier, for a web service. So there was no support in Spring Cloud for, hey, I just want to bind a web service, an HTTP-based web service. So what we did was we created, the nice thing is that Spring Cloud Connector was designed so that it's extensible. You can add additional types of services into Spring Cloud Connector so that later on when I do that binding, it'll automatically parse the environment variable and it'll automatically create the right object for me. Now in this case, I didn't create an object, and I believe that you're going to see in the next session some cool stuff that was done around creating objects for web services. Ram Navas is in the back end nodding his head. So come back, stay for the next session, and you'll see this example get even cooler. What I simply did was I simply created the extensions in there so that I didn't have to parse the environment variables. That's all I did. And I won't go through the code here in detail, but there's a couple of things here. The one thing that I do want to draw your attention to is the tricky part at the bottom. So you create these couple of Java classes. You can include them in your project. So I included them in the WAR file. But then you also have to put a couple of files into your class path. It's very specific, the name of the file. And then inside of the name of that file, you basically have to give it your fully qualified class name. And that's how Spring Connector knows how to find those classes. I say that it's tricky. It is documented. And the documentation is right there in that URL at the bottom. These slides are all going to be available, so don't worry about writing that down. But I would assert that it's very dense. It's documented, but again, I'm not a Spring expert. I read it, and I reread it, and I reread it, and it wasn't quite working, and it's very dense. So I just wanted to alert you to this, that if you do this, your WAR file builds, your class is included in the jar file, and for some reason, it's not. The error message that you'll see is that it'll basically say, hey, I don't know what to do with this. It'll start treating it as like a basic connector, and you want it to be treated as a web connector. This is the tricky part that you missed. Okay, so that allowed me to separate things back out into this topology. So let me show you very quickly, and in fact, I'm going to start this running. I'm going to come over here, and let me. I am going to start the deployment running. Deploy. And I'll explain to you why I'm running a deployment script in just a moment. So I'm going to start the deploy. It takes about 5 or 6 minutes, which is probably, which is about the time that I have left. I have about 10 minutes left. So that'll be good. It'll be deployed by the time we get back. But let me step you through what we've done then, what is happening behind the scenes. We already did this. I did this through the UI. I created the Trader SQL, and I created the Trader messaging. So I created instances of these two services. Then I did a CF push. I pushed the Trader back, which is, remember, that fulfillment tier. I pushed a WAR file. I bound that WAR file to the message broker, and I bound that WAR file to the data tier. Okay, so these are a couple of commands. See, what you're seeing now is the whole deployment of this application. Then I did the same thing with that services tier at the front end. I pushed the Trader front, I bound it to the message broker, and I bound it to the database. Then I did something that's kind of interesting. And let's see, where's my animation? There you go. It's a little hard to see. But I turned Trader front. Remember, it was turquoise before. I kind of am sharing the color scheme now. Trader front is turquoise because it's an application, but it's also green because it's a service. How did I do that? Well, in Cloud Foundry, you have the notion of something called an external service. So you can have something that isn't a managed service. That is, it doesn't show up in the services marketplace. It's a service that is just running somewhere. It could be your Oracle database that your Oracle DBAs are running. It could be your custom time series database that you have in your organization that's being run by some ops team. Or it could be some service that's running on Cloud Foundry. It's just a service. It's something that's running out there. And what I need is when I want to bind an application to that service, I need those credentials. I need the endpoint of that service and any other credentials to be served to the consuming application. So the consuming application, of course, is going to be the web tier at the top. So I need a way of serving the credentials for Trader Front to the web tier. Well, those external services, be they running on Cloud Foundry or be running on somewhere else in your data center, we have a command that is create user provided service. So short for that is CUPS. So I could have written CF create dash user dash provided dash service. And what I do is I name the service. So remember, we've talked a lot about looking up services by name and how the Cloud Connector, Spring Cloud Connector does that for me. So I give it a name, Trader Front, and then I hand it the credentials. So when I did those create services before, I generated new credentials, and then those new credentials were served in the environment variables. In this particular case, I'm not creating new credentials. I'm just saying, hey, I know the credentials of a service that's running somewhere. And when I bind to this, these are the credentials I want you to serve to the next tier. So you can see here that I gave it the URI of traderfront.cfapps.io. Now, finally, I can push the Trader Web, and I can do a CF bind service, Trader Web to Trader Front. Notice that the CF bind service is absolutely no different for when I bound to message broker and data tier. It's exactly the same binding. And I cannot emphasize to you enough how important that is, that part of our services protocol allows you to bind to services whether they're part of Cloud Foundry or not. And that's a hugely, hugely powerful construct that allows you in the enterprise to say, how do I migrate to this platform as a service thing? Well, you're going to do it incrementally. And sometimes at first you're going to start leveraging services that are not part of the Cloud Foundry ecosystem. And so that's incredibly important. And that's it. That's what we have running today. So let me go ahead and show you this. Oh, and look how slow it is. It's still deploying. So we'll come back to that. It usually only takes about 5 or 6 minutes. I don't know why. It must be actually, we're uploading those WAR files, so I bet that was where the time was on the wireless. Question in the back?
So WARs is an issue in Cloud Foundry, mainly because of the subdomain. Each application deployment is a new subdomain. But WARs doesn't really apply to an XHR request if it's a relative URL that you're calling. So is there a way in Cloud Foundry to make an application deployment a context of the original, of a single domain as opposed to always requiring it to be a subdomain?
Yep, so I'll repeat the question. The question is, well, Crosssite scripting came in here, the issue came in because we have 2 different subdomains. And the reason that we didn't have to deal with it before was because I could have things, they were just different paths to the same domain, different paths to the same domain. Does Cloud Foundry allow me to deploy using that? And the answer is no, not today. We do occasionally get those requests, and it is something that we are considering whether we want to, and there's a number of different permutations. Some of those permutations might be, hey, allow me to deploy 2 WAR files into the same container, and then be able to configure those servlets, and so on. So that's a much longer conversation. The short answer is no, we don't allow you to do that, and we can have a conversation offline of why we haven't done it yet, because there's reasons for it. Yes? The question is, how portable is this to some other cloud environment? So I'll answer that question 2 different ways. The first answer is that I want you all to know that Cloud Foundry, being an open source project, has more than one vendor providing a solution. So Pivotal provides Pivotal Web Services, which is what I've been demoing on here. We also provide a commercially licensed version that runs on-prem. We have a foundation now that governs the open source that has over 40 members in it. Some of those 40 members are providing commercialized versions of Cloud Foundry as well. So companies like IBM, CenturyLink, many others are providing Cloud Foundry, Active State. They're all providing Cloud Foundry available either as on-prem offerings or up in the cloud. So you can go to Bluemix, for example, and that's the IBM offering. So the first way to answer your question is that if you're thinking of it from a vendor lock-in perspective, you can take anything that is crafted for Cloud Foundry deployment and deploy it on other vendors' offerings. Of course, their services might be different, and so you would have to make sure that you have equivalent services on those other platforms. Then the other part of your question, and probably the part that you were really asking, is, okay, you built all this to deploy on Cloud Foundry. Can I deploy it in something that's not a Cloud Foundry-based deployment? And the answer is, in theory, sure. Now, Spring Cloud Connector is something that we're leveraging here. It has support for Heroku. So at a high level, it's probably most easily to say, well, maybe I can take it over to, if I've abstracted things appropriately, maybe I can take it over to Heroku directly, and all of that Spring Cloud Connector stuff will work for me, will do the work for me. If you're taking it to something that doesn't have support, so again, we're using Spring Cloud Connector here. If there's no support for the cloud that you're going to, a Spring Cloud Connector, then you might have to change things. But you won't have to change your WAR files. Everything that we've done here so far, with the exception of the CORS filter, where we actually had to add some additional code, all of the changes that we made were purely configuration changes. They were all changes in the Spring config file. None of your application code changed. So, yep. Yes, another question. Very good. You're asking about service discovery. I'm not going to answer that question because, number one, we don't have a lot of time, and there are some talks that are coming up on that. There is a colleague of mine is doing a talk on microservices this afternoon. It's in this track. I don't remember if it's in this room. Matt Stein is doing a talk on microservices, and he will be talking about service discovery in that talk. So I'll refer you there to start. Okay, let me see how much time I have left. I have 1 minute left. I'm very quickly going to talk about session state caching because, the gentleman who asked the question has left. Oh, that's too bad. So session state caching, if you recall, he asked the question at the beginning, hey, when you recovered that application instance, what about user sessions? User sessions don't belong just in the application container. This particular application, this Trader, Spring Trader application, was initially designed to do session state caching this way. Gemfire node embedded in each one of the Trader front instances, and they were doing peer-to-peer messaging. So session state was done peer-to-peer. When you deploy this onto Cloud Foundry, however, each one of those instances of that application are deployed into their own in their own containers. Those containers have firewall rules set up so that they cannot communicate to one another. That's by design. We are designed from the ground up to be a multi-tenant solution. So each one of those is, and it would be bad if you allowed two different containers that are running on the same VM to talk to each other. Just open. And by the way, there are some solutions out there, that container manager solutions, that do allow you to see, for example, from within one of those containers, what is running in other containers. Not a good thing. Not a good thing. So we can't do this via peer-to-peer messaging. So what we're doing instead is using Redis or something like Redis to do session state caching. And the Java build pack that we have In version 2.1, it was maybe about 2 months ago, they released something in there where if you bind your application, so you'd be binding to an additional service, if you bind your application to a Redis service with a particular name, it will automatically do the configuration so that all of your session state is persisted to Redis, so that you now have session replication into Redis in each one of these instances. So now if one of those trader front applications goes down, and when the new instance comes up, it'll connect into Redis and it will have the session state that's there. So my final punchline is, this is where we started. This is now, I encourage you, the call to action is go ahead and go to the GitHub repository, grab it, sign up for PWS, go ahead and deploy it and start playing with it. And finally, I've already talked about each of these 2 sessions. Ramnavas and Scott are coming right up, and the microservices talk is at the back end. So I'm going to skip. The application should be up and running now. You can actually go ahead and take a look at it. It'll be out there. Thank you so much for your attention. And if you have more questions, I will step out into the hallway so that Scott and Ramnavas can set up and get started on their session. So thank you very much.